Thank you, Victor. I'm very distracted because we just had a 30-minute talk about hunting mushrooms, so I don't know how I go back and talk about LLM workflows now. But thank you for coming out this morning, for getting out of bed early and coming to see this talk. Don't have to, and I appreciate that. I'm Steve Pavolny, Senior Director of Security Research at Exabeam. Also co-chair our Generative AI Council internal to Exabeam, so spearheading a lot of the innovation research projects around AI, agent building, and automation. So very excited to be here today to talk about this topic with you. I'm going to go ahead and read every word for word on the disclaimer slide. No, I'm kidding. All right, this session is focused on a few areas. We're going to briefly talk about some of the top tools and automation frameworks that are available today. There is going to be some stage setting here and some assumption that you come in with some knowledge. This will be a fairly technical talk, but I'll try to keep it high level enough and practical enough to have some takeaways here. What I want to explore is how we take LLMs today and some of the real world applications in security. We're going to incorporate best practices around prompt engineering and talk about how to get the maximum amount of value out of your prompts as you build workflows using AI agents. And obviously integrating AI into your LLM workflows and your automation frameworks. We'll come away then with obviously some lessons learned, some of the many challenges putting this together and practical insights. But the majority of this talk will be focused on kind of a workshop style walkthrough of building an agentic workflow in a tool called N8N. So it's just one of many frameworks that we'll get into today. Okay, let's start with a little wake-up question. We'll start with an easy one. Anybody remember what year ChatGPT was released? Yell it out or raise your hand, either way. Yep, 22. I heard that all around. Very good. Okay, let's go slightly harder. What month? Close. What did you say? November. November is right. Okay, how about the year the first iteration of GPT was released? Okay, this question was kind of meant to stump you. It's been forever. June of 2018 was the first iteration of GPT, and it took almost little over 4 years for us to see the mainstream application as ChatGPT came out of the woodwork and the world changed overnight. So it's kind of funny looking back at both how recent and how long ago that feels. And that was GPT-1 with 117 million parameters. Now we're talking billions of parameters. I think in the near future, we may add a 0 to that number, but exponential growth in the field of AI. But also, this has been around for 3/4 of a century. So, Alan Turing first proposed his paper on, what would become known as eventually as AI, on computing machinery and intelligence, and theorized the Turing test, the ability to tell the difference between human and machine. And since then, we've had sporadic, large bouts of growth in AI. But if you look at the last 5 years or so, I could probably add 100 X's onto this graph just to talk about the growth in the last 3 to 5 years. I think if you haven't heard the word AI at this conference every 30 seconds, you probably had too much to drink last night or something. But I mean, it's everywhere and everyone's talking about it, and for good reason. I really believe that this is a pivotal technology change and a shift in the way that we're going to do things for at least the rest of our natural lifetimes. So I just want to focus on this graph a little bit on 2022, where we talked about ChatGPT coming out, 23, where GPT-4 was released, and multimodal AI expands. We start to see reasoning and planning models. In 24, the emergence of RAG, Retrieval Augmented Generation. We'll talk about that a little bit shortly. That became standard. Start to see the release of many open source LLMs and the proliferation of those LLMs, cost driven down. And now as we go into 2024 into 25, Model Context Protocol, MCP, and really AI agents starting to demonstrate full autonomy, agentic systems becoming the topic of 2025, and this exponential growth. So just a little bit of overview there. Let's pivot to some of the LLM tools that are available today. Again, this could be probably a slide deck in its own, as you know, but these are just a few of the top LLM models available today, at least some of the larger ones that you may have played with or used. At Exabeam, we're actually a fairly heavy GCP Google shop, so we use Gemini for a lot of our development, but we've tested and iterated with dozens of different models, open source to proprietary, frontier to minimal. So lots of tools to play with. I guess that begs the question of why do we need LLMs for security? And there's probably dozens of answers on this, but I think some of the ones that I want to focus on today are they help us to automate our workflows when it comes to providing text-based input and output. And we'll talk about some of the applications of that as well as we go through a workshop today. It helps if you're in the security space, especially for Security Operations Center, or if you're on the defensive side of security. We think about reducing that analyst workload, whether it's an investigative analyst, forensic analyst, defensive, pen testing. All of these things can see real value out of leveraging LLM-driven workflows here. And it helps us generate contextual insights from either raw, structured, or unstructured security data. So LLMs are not very good, actually, at dealing with massive amounts of data without very clear instructions, refinements. But when it comes to post-processed or structured data in the context of security, it's actually a perfect application here. And finally, we're a SIM company, so a lot of our vendors are SOCs, and it helps us to automate the SOC efficiency, taking down their investigation work times, sometimes by an order of magnitude, 8 to 10x. There are a number of security considerations, which I'm not going to focus on too much in this talk today, but important to be aware of as you're developing both automation or workflows and leveraging LLMs. Some of those considerations are data privacy and compliance, whether you're putting sensitive information in or consuming sensitive information in the logs, PII, prompt injection risks. I stopped by a booth yesterday of an old friend who built a universal adversarial prompt, which applies to every modern frontier GPT out there, or LLM out there, and basically can bypass the guardrails of every single one of the LLMs that I showed you before. So you have to be careful when you're developing prompts that you're testing for and sanitizing your inputs. Model bias and hallucinations, these really became a major term over the last couple of years as well. Models are inherently biased based on the information that they gather. Turns out the internet is not the cleanest of sources, but when you get a lot of information, you can start to refine and eliminate those biases. And as we provide things like context and reg, which we'll talk about later, we can start to reduce that bias and those hallucinations. And finally, API security. So since the focus of this talk is automation, it's likely that you'll be incorporating various APIs into the agents that you're building, and it's important to make sure that you have a fundamental sense of security around those APIs. Many of the workflow automation tools kind of just shove that part of the puzzle under the rug here and don't pay attention to the security of the API. We'll see them passed in plain text. We'll see them passed unencrypted sometimes within certain aspects. So just make sure that the API security is an important part of what you're doing. Okay, on to prompt engineering. Prompt engineering, obviously, as we all know, is the practice of crafting prompts to guide the responses from your LLMs. And I'm sure there's many talks at RSA this week about how to properly craft prompts and how to refine them and to get the most out of them. So I'm going to be very high level. This is, again, probably, every slide in this deck could probably be its own talk. But I do want to give some basics here. So one of the things that I learned throughout this project of building these slides and the automation for this is the importance of and the sensitivity of your prompts, especially as you think about building complex workflows where not only are you doing things like system prompts, but you have descriptions for your agents, you have text-based summaries of your vertex stores, all these concepts we'll get into shortly here. And many of them, even if they're not specific prompts to the LLM, are keywords, and they are used by the agent or by the model to interpret your intentions. So when you're crafting any of those text-based descriptions, summaries, or prompts, it's really important to be very precise. And if something is coming back with a hallucination, don't always assume it's just the model, right? Yes, as you get to higher models and larger parameters, you're likely to get better responses, but it's equally important that your prompt is efficient. So a basic prompt, analyze this security log. Might work, depending on the model. An optimized prompt might be analyze the following log for indicators of compromise related to phishing attempts, highlighting the anomalies. Now, optimized, very short and sweet, very clean. Just to give you an idea, your actual prompts that we'll see throughout this are going to be much, much larger, much more specific, and have a lot more personality to them. What do I mean by personality? When you are creating your prompts, I think of sort of 4 key areas for efficiency when you're developing prompts. The first one is the persona. This is not a necessity, but it is very helpful to get the LLM to, I hate to use this word, think, but to think like the human being or the person, the persona that you're developing it in. So our example today is going to be around, as you'll see, automating threat intelligence for SOC log ingestion. And so my persona might be a security analyst. And the instructions in there need to be clear and concise. Your job is to summarize the incident, doing X, Y, Z in whatever context it is. Here we say explaining the threat, what actions the LNS may want to take. And then you can refine your initial instructions. Again, a very simplistic example, but instead of repeating the details of each event when you respond, explain the connections between them, how together they work to indicate the severity. So these are the refinements, and I think this is the most important part of the prompt, is digging down and being very, very specific. Now, one thing I don't have on the slides, but I'll call out here as well, is LLMs are very sensitive to we'll call it typography. So if you want to call out a specific instruction in your prompt or a format, you can do things like putting it in quotes or chevron brackets. And because it's a predictive model, that'll actually stand out to the LLM, and it'll have a higher chance of prioritizing those instructions. So you'll often see when you're looking at complex prompts, you'll see a number of single quotes, double quotes, chevron characters, new lines. All of that formatting is really important. Not essential, but important to how the model is interpreting your prompt. And then finally, the output and format. So how do you want to format your summary? And this is very specific. You can give it clear examples of what the format should look like in line in your prompt. You can give it a summary overview like we did here, and tell it exactly what you want to see in what format. Then we go to context and controls. So controls, I'll kind of breeze over here. This is things like, models may have a temperature setting where if you set a higher temperature, it will get a little more creative in its responses and a little more dynamic. And if you lower it down, it'll be a little more static and consistent. And then the context data, which I think is probably one of the most important parts of your prompt. It doesn't have to be provided in line. The example I was giving actually is a prompt that we had for an earlier version of what we had as a Copilot. And we did provide our RAG, our context in line. So retrieval augmented generation, I don't think you'll find this as a formal definition anywhere, but maybe it'll stick, right? Stuff to make responses better. I'm sure the data scientists in the room are going to be angry at me for this definition, but that's really what it is. It's using data that you retrieve either inline or from an external source to augment your prompt and to provide context or a larger understanding of what your prompt is for. It can be structured or unstructured data taken from an external source or, as I said, even augmenting the prompt in line. So in our example, because it's a SOC analyst looking at logs, some of the actual context or reg that we provided to the model was a JSON formatted detection. So this is the raw JSON from a detection in the SIM. And that is context that we're going to give the model so that we can ask very specific questions about those detections instead of just general security or internet-trained questions. When it comes to tuning your responses for when you get responses back from your model or from the LLM, you will often see, especially in the early stages of development, hallucinations. We'll call it fake data. That's not necessarily always true, but it's the model predicting something that it wasn't trained on or doesn't have former knowledge of. So it's essentially kind of making something up. And this is where both the model and its performance, as well as the complexity and specificity of your prompt are very, very important. So cross-check your responses with external sources to determine if something is a hallucination. You have reasoning models now today that can reason on themselves based on the output that they delivered. So go back and sort of fact check my own responses. And you can even do things like implement confidence scoring mechanisms. So based on how much reg or context data you provided, you could have a higher confidence in the output that you're being given. And then we see excessive verbosity. So sometimes your prompt or your model, especially with higher temperatures, will just start spewing out data or responses and just be way too extensive. You can actually limit those responses in your prompt. A great example is we were trying to create case names in our SIM platform, right? So we didn't want them to be more than, on average, about 10, 15 words or less. So you can specify when you're creating these case names, keep them to 10 words or less, and here's an example of what that looks like. Never, in bold or capitals, never go beyond 10 words. That'd be a great way to bound that. And then, of course, I mentioned earlier security risks in the responses. You want to make sure that you are trying to filter and sanitize responses, whether this is using another agent, whether it's using automation, a human being in the loop, or any of the above. Security risks in your responses is an increasing threat. And again, not a large focus on that today. Okay. I'm going to pivot to some of the automation frameworks. We've covered LLMs and models fairly extensively. This is, again, a very, very tiny handful of maybe some of the more popular, but just a small scattering of some of the many frameworks available for integrating large language models into your workflows. LangChain is very popular. You've probably heard of it. Framework for integration with LLMs. I'm going to use N8N today for our walkthrough for our workshop. It's a really cool tool, pretty secure, AI native, comes with extensive workflows and many, many node types that you can integrate. I call it a low-code application. It's very UI friendly, but you can do a lot of code development in it as well. AutoGen, Windmill, Google just released their agent developer kit, which I have plans to investigate very shortly here, but looks very cool. It's a code-heavy platform for now, so not super UI heavy, and many more. So pick your favorite based on what you're interested in doing. Some of the concepts that are present in almost every single one of these automation and workflow tools is the initial setup. You're going to have to do a little bit of legwork to go out and create the APIs or use the APIs that you want your agents to work with, downloading or creating the API keys, setting up instances if you want to run your workflow locally or in the cloud. All this is part of the setup. But I'll show you today you can get through this pretty easily. There's some great GitHub repositories that let you get through this quickly. And then there's the concept of nodes. This is especially present in things like N8N that have a visual interface or LangGraph where you're going to use pre-built nodes that you can use to build these workflows. You can also customize nodes. You can build them from scratch. But a node is just a point in your workflow that connects to other nodes. We'll talk about a few of these as we go. We have trigger nodes, agent, code-based, data transformation, flow, core, human in the loop, many, many more. And then one of the things I really like about some of the automation tools today is you can do something called session pinning and rerun. So when you're testing your automation and you're doing an initial run of it and seeing how the LLM responds or what the output looks like, you can pin the data that you sent into it, just like you pin a conversation on X or LinkedIn or whatever, and you can rerun that, re-execute with the same data. So you know that what you're putting in is always the same thing as what you're getting out, and you can play with what's being provided there. That's kind of the concept of prior executions. Again, we'll see all of these a little bit live here, or in person here soon. Execution tracing is a really cool way to debug what's happening. So as I'm going through and building my N8N workflow, and I get an error from Llama, and it says, tools are not supported. I don't know what's going on there. I don't know what that means. But with execution tracing, you can actually see in your workflow graph where the error happened. You can go in and trace down or debug what happened. It'll be very visual and gives you a great way to debug where issues went wrong in your automation workflow. Now, many of these vendors offer libraries of templates online, so you can go and look at pre-built, community-driven templates that have these workflows already done, either for inspiration or if you want to adapt it. There's thousands of them out there. I'll give you a link at the end of this for the N8N community workflows. I'm certainly not pitching N8N. It just happens to be the one that I used for this. Okay. In a real-world use case, where would a SOC use an automation agent or a set of agents, for example? One of the ways that I think about this is an agent-driven threat intel correlation via chat interface. That's a mouthful, but the idea is here, we could give the SOC a chat interface that uses modern LLMs to enrich some of their logs or correlate information in their logs with threat intelligence. It's a pretty simple integration here. So the security analyst would receive an alert from the SIEM. The LLM will automatically enrich that alert with external threat intelligence. Let's call it VirusTotal or Mandiant or whatever it is. The AI summarizes and provides recommended actions, and then the analyst, if we have a human in the loop, will verify and execute those responses. Agents and agentic workflows. Oh, I mentioned the term agent, and I've intentionally waited to describe it until now because we're going to go into this in a little bit more detail. I imagine if we asked everybody in this room to describe agents or agentic systems, we would get 100 different answers, at least versions of it. It is being more clearly defined today, so I'm going to give you my interpretation of it. An AI agent is a purpose-driven component addressing a specific task in the form of AI. Agentic AI is an autonomous system that can learn, it can operate independently, and it can adapt to changing conditions. So there is nuances there, not a dramatic difference, but when you hear a vendor pitch agentic AI and talk about their agentic AI solution, dig a little bit deeper. You know, they may be using agents, they may be using machine learning. They may be using simple automation with no agentic capabilities in it. So it's this combination of things together that brings the automation, the reasoning and learning capabilities that makes something agentic. So I think that's really important, as this is a term that's being way overused today. So an agent might suggest recipes, ingredients, and directions for meal planning. Agentic AI might build the weekly meal plan, shop for the groceries, schedule the pickup, and unfortunately, maybe a few more years before it cooks the meal for us. But with the rise of robots, it's not far off. Okay, let's get into the workshop. We're going to build a workflow here in N8N that is going to allow us to do the exact walkthrough of what I gave before, enriching security logs with threat intelligence automatically. We'll call this Steve's Chat Agent for Security Operations. This will consist of, in our workflow, an LLM agent, a chat agent, a vector store, which we'll talk about shortly here, to both read and write into for our RAG data and our context, and some API requests. We'll use the third-party threat intelligence from VirusTotal because it's very easy to integrate. And we'll be leveraging SIEM logs or detection events from SIEM logs to enrich them. As I mentioned earlier, you can do all of the manual setup on your own to build workflows, but there are some great tools out there that will let you do this within a matter of minutes. Like Carlos here in the front room on my team introduced me to this, but this is a package that you can find on GitHub that's specifically tailored for N8N as a workflow automation tool, but it's self-contained or self-hosted, and it contains Ollama for open source LLMs, N8N for automation, has Docker, so you can containerize the entire thing and run it all on local instances. It has Quadrant for vector stores, and Postgres for agent memory and for workflow storage. So it gives you all of the fundamental tools that you need to do to develop basic to semi-advanced automation workflows. And of course, you can self-install any additional components that you want to add in and leverage in your workflow. I'll give you a link at the end for that as well. First step here is going to be, and let me back up for a second and walk through how we're going to do this. So I wanted to originally literally run this almost as kind of like a live workshop and walk through building each step of this together and kind of taking you through how to create the nodes. The reality is that was like a 6-hour workshop, and we just don't have the time for it. So what I did instead is worked ahead, built the entire workflow. I'm going to show you what that looks like, and then we're going to go through and break down each of the pieces of it, how they're built, and some of the key components of it. So the first step here, installing Docker. So you'll just clone the GitHub repository for the N8N self-hosted kit here and run Docker setup. There's all sorts of instructions with the README here about how to do this. You'll choose which type of CPU or GPU you're running, AMD, NVIDIA, non-GPU if you're running it from a Mac, and then you'll configure N8N. So that's as easy as logging into N8N, creating an account, and you're off and ready to go. So once you have Docker up and running, you'll see, you may have to have good eyes here, but you can see it's automatically running Ollama, it's automatically running Postgres, Quadrant, and N8N. So all I did was spin up the Docker instance, install the self-hosted kit, and all these services are running in Docker already. So it takes care of a lot of the overhead for you here. All right, to quote Princess Bride, we're going to jump ahead and show you the entire workflow before we continue. So this is a very simple summary of the workflow agent that we're going to build today, and I'm going to go through and highlight each piece of it. Unfortunately, I do have a mouse. Okay, so the components you're going to see here are a small workflow that's going to do the reading from our vector store. This is where we're going to store the logs for our agent and read from. The writing into our vector store, this is where we're going to write and tokenize those logs and store them for quick retrieval. And then our main kind of agent here is a chat trigger with our AI agent that uses the Ollama chat model, has Windows memory, and has a tool for VirusTotal lookup. So we're going to add a tool to do that API lookup. So this entire workflow is a self-contained workflow that will take those logs in via chat, allow us to ask questions about them, enrich them, and provide those responses. Once you have Docker running, you can browse to your local host if you're doing this on localhost, and I highly recommend that if you're working with anything sensitive or proprietary and you don't want to use the cloud-based version here. N8N on localhost, and it already will give you this demo workflow. So it starts you off with all the components. I haven't built a single thing here yet. And if we look in N8N, we then see this initial workflow. So again, I haven't dragged and dropped anything. It just gives me a chat trigger. It gives me a basic LLM chain, and it's integrated with the Ollama chat model. So very simple, but you can actually use this without having to write one line of code or without having to configure anything. You're probably at about 5 minutes of work right now to get to this point of testing any of your local LLMs with a chat trigger. So let's look at how this works. Again, this is in N8N, so this is a local chat instance provided in your automation framework. It's very, very easy to test. It's just the bottom half of your screen. And I can say, how good is the RSA audience? And you can see on the right side, the live logs. It went out and it queried the Ollama chat model. And it has clear hallucinations. So if we look at the response, we're not going to read it all, but RSA, the Royal Society for the Encouragement of Arts, Manufacturing, and Commerce. Well, the model's clearly completely off. It has no idea we're dealing with RSA, Rivash, Shamir, and Adelman. It has no clue that that's the context of this conference. It hasn't learned anything about what we're asking it. Doesn't even know that we're talking about security right now. It's just an LLM prompt, and that's the first acronym that it decided to respond back with. So kind of garbage here, but a great starting point. Okay, I'm going to breeze through some of the common nodes here, but I encourage you to look into these a little bit more. But as you think about adding in additional functionality to interact with your model, there's some common nodes that are built into N8N and many of these other frameworks that you can use. So we have an agent node, which we're going to use shortly here, a chat node, which you just saw, the LLM chain, which was built in, and then we have things like text classifiers, embeddings, vector stores, and a lot more. So I'm going to use each of these, but there are literally hundreds and hundreds of nodes. So you can integrate with a Slack instance if you want. You can call any database that's has any kind of market share will have a node built into it. You can use any model that you want to use or integrate with them. There are hundreds of options here for how you use and transform your data. But the first thing I'm going to do is I'm going to take this, what was formerly, I'll bounce back here a little bit, what was formerly a basic LLM chain that was provided to me by the initial setup, and I'm going to change it to an AI agent. So this is another node that's supported by N8N. And this allows us to integrate tools and tooling, or tool chains, so that we can drive specific actions. So now, instead of just a chat model, now you can see we have memory and tools. Memory we'll get into shortly, it's pretty self-evident. And tools are very specific, well-named, tools that provide specific actions or operations on the data you want. So think about when you go and type into ChatGPT, what's 4 plus 4? Well, there's probably a math-based tool that it's calling to actually do addition, subtraction, multiplication, or specific operations before it returns that. It's not just making up a response for you. Earlier versions did, but now as tools are increasingly added into modern LLMs, there's very specific applications for them. So you can see here, the first thing I'm going to do in this AI agent is connect the chat trigger back to it. We'll leave Ollama separated for now. And you will have to work through a lot of understanding what each of these fields mean. I'm not going to describe everything, but I'll try to give you some of the basics here. We can see that we have a tools agent that we can connect to. The source for the prompt is the connected chat trigger node, so anything that comes in from the chat is going to be our prompt. And you can add specific prompt messages here. So for example, I pinned this workflow, and we can see from the chat input here, my question is being passed through. How good is the RSA audience here? You can also provide a system message, and this is where you can kind of tell it a little bit of that persona here. You're a SOC assistant designed to enrich detection logs with threat intelligent information from VirusTotal. A system message gives it the context to understand what its task or purpose is. Okay, now we're going to update the response with some prompt instructions here. So what we'll see is if we ask this question again, now that we have an AI agent involved and a system prompt, I don't have a same question. I don't have any specific information on the RSA audience you're referring to. However, I can tell you about RSA and its properties. So it doesn't know anything about the conference here. It's still a little bit of a hallucination. I would have liked it to know from audience that it was a conference, but it at least knows that we're talking about the security RSA at this point. So a good step. Now we're going to choose the model. So within the AI agent, you can choose which model you want. We're using the local Ollama service that comes with this package that's built in. So we can see Ollama, the model is Llama 3.1 latest. You can absolutely download and change that model anytime you want here. It's very, very simple. So if you go to ollama.com, you can see a list of all of the models that are supported. And here's the models. If you click on that, you can type in what kind of model you're looking for. So if I want to use Qwen as a model, it'll list all the models. And you can even click on the button here for tooling. So if the model supports tooling or not, which if you're building automated workflows, you almost certainly want to have tooling supported by your LLM here. So it'll then filter and refine all the models that are supported here, and you can change to one that has a lot more parameters, a lot more intelligent for responses. Okay, next thing we're going to do is add in the threat intelligence tool. So remember this little button here, we can literally just click the plus. It'll pop up a window that gives us all of the pre-built tools or tool capabilities in N8N. And I'm going to use an HTTP request tool in this case. So that allows us to call an HTTP request using an API and returns the response data. Now, this is where you're going to want to go out, and part of that setup is having made sure that you create your API key for VirusTotal. It's free to do for the free version of it, and you can do things like query for threat intelligence and get reputation responses from it. You can give it a description here. So this description, again, is to highlight what this tool is used for. You'll see I'm using special characters here to tell it I'm doing a reputation check for IPs, URLs, domains, or hashes, and then tell it explicitly we're going to use VirusTotal to go look up these reputation. The method and everything I won't go through, but you just put in the URL for VirusTotal's API, and this will work very, very simply. It's basically all drop down. And then you can set up your VirusTotal account as well here. So predefined credentials, if you click on that button here, you'll see where you go in and just add that API key. Okay, so now that we've got a basic integration with VirusTotal and it's very easy to test in line, I talked about executions before, you can click literally a checkbox, it'll test that the API works and it's responding. We'll skip over that for now. But in your prompt for this tool, you want it to be very, very highly specific. So, it can handle things like variables. So in order to use this tool, replace the, and then I have JSON brackets here, IOC types from the URL with either IP addresses, domains, files, or URL. And those are the exact strings typed correctly that belong in the API response when you're querying VirusTotal. So if you go out and you actually query VirusTotal, you're going to add, see here, it's probably hard to see at the bottom here, but virustotal.com/API/v3, and then the IOC type and the IOC value, and that's these exactly here. So you can be very specific in the formatting of your data so that the API knows exactly what to use here. Okay, let's do a quick test on this portion of it. So within the tool, now I ask a question to chat, what's the reputation of IP address 198, et cetera. And we can see that it provides a response from the model we've chosen. I think this is on Qwen at the time. And it tells us that it's associated with malware and that there were 5 samples identified as malicious. If I go out to VirusTotal, I see 5 out of 96, so it is accurate here. And the security vendors flagged it as malicious. So that's a quick way for us to validate that the tool is working as expected. Now we're on to enriching logs with our threat intelligence. So the end goal being, how are we going to use a vector store to store our SIM logs and enrich this dynamically so we don't always have to use a chat instance. So the final step here is going to be integrating the vector store. So let's look at a sample log. Hopefully you have this all memorized and you can read every single word of this by the end of the talk. I'm kidding. Obviously, I'm calling out some of the things that are important to pay attention to here. We have a SHA-256 string, which is a file hash for a malicious file that's observed in this log or in this detection. And we have a remote and local IP address. We're actually only going to use the SHA hash for the demo here. But if you just pay attention to the beginning characters, we remember it, 226A is what this SHA hash starts with. And we're going to be providing all of these logs into our vector store. Okay. The instructions for how to do this. So we need to have an ability to write into the vector store and the ability to read back from the vector store. The vector store we can think of as a database that's optimized for quick reads and writes and has the ability to tokenize or optimize the data that's put into it. So what we'll do is we'll add a new manual trigger to integrate a vector store. So in N8N, you'll have a pre-built node for a vector store. In this case, we'll use Quadrant. We'll add that, comes with the build. We'll add a set node to transform our data from a raw log into structured data. And then we're going to create, and again, I'm going to go a little high level here. This is going to be some homework, but we're going to create a Quadrant collection with the sample log. So the way that you do this, and you'll have slides later to go do this, you'll browse to localhost over the Quadrant port, go to the dashboard, there's a quick start button, you literally click create a collection, and that will automatically create the framework for your collection that you're going to use in your vector store. And then you'll just import that. It's actually really easy, even though it sounds complicated from here. We'll load that collection into our set node. We'll create what's called embeddings, which I'll cover in just a minute for our Ollama model. We'll add a default data loader, and we'll split up all that data into chunks to optimize loading it into the vector store. Okay, so again, I know that's a lot. I'm going to come back to all those points in just a minute here. And then on the reading side, we're going to read out of that vector store as well to retrieve data from it. So when we add, we'll add a new vector store tool again, so the same exact tool, but we'll use this one to retrieve logs instead of to write them. We'll add the same embeddings model to that vector store, and we'll update the AI agent with a prompt that incorporates the knowledge that we've built a vector store and when to use it. Okay, so the vector store setup looks a little bit like this. We've dragged in a node for the vector store writer. We put in a set node, which all it does is it has our actual log samples in there. So I just manually copy a log sample in here. We have 3 important components. One is the Ollama embeddings. When you are creating a vector store, you're going to create embeddings from your text-based data. And what this does is it creates mathematical representations of your data. It writes them into your vector store in a way that's quick and easy to retrieve and reference. It's really important for using vector stores. The other 2 components are a data loader and a recursive text splitter. I'm not going to go into too much detail on these, but the data loader is the node that helps you load the data into that vector store. And the text splitter allows you to split large volumes of text that you're writing into that database up into chunks to manage it. It's essentially an efficiency process here. Okay, so there's the Quadrant vector store node from N8N. There's our set tool for the sample log. This is our Ollama embeddings. I'm just showing you the nodes that you'll drag and drop in here. And that's everything that you need here to create this. So in the interest of time, I'll kind of move a little quickly through this piece. But the vector store setup is actually really easy. It's very similar to how we did the tooling of VirusTotal before. You will just select your Quadrant API database. You'll enter your API key that you've built there. And for the set node, the sample log, you can literally just copy and paste it as raw text from your log here. The Ollama embeddings has a bunch of pre-built embeddings models. So for this one, we just connect it to the Ollama service, and we tell it we're going to take the latest text model embedding from Ollama, and it'll do everything automatically for you here. And finally, the recursive text splitter, I chose chunk size of 1,000 and overlap of 100. It's not super important what you do here. It's just making sure that you choose a consistent format to split those chunks up into. Memory is an important component that helps you keep track of your earlier responses. So when you think about ChatGPT and you ask it questions and it knows the context of what you asked before, same exact thing here. I've chosen a context window length of 5, so it'll remember 5 of your previous chat interactions. And that brings us to our final workflow. So we have our, again, just to recap, we have our quadrant store to write our logs into. We have our quadrant store to read out of, and our main workflow, which integrates all of those tools together. So let's look at a little demo here for the last couple of minutes. And we may not have time for questions, but I'll certainly stick around afterwards. So this is our same workflow in N8N. On the bottom left, I've asked it, can you find hashes in the stored logs? And you'll see it executing from our chat trigger, calling the AI agent, and going to our Ollama chat model. Well, the Ollama chat model doesn't have enough to answer that, so you'll see quickly it went over and called our quadrant workflow tool. It knows that it needs to retrieve logs. And shortly here, with those logs, it's going to go and execute our virus total lookup. So you can see it following the virus total lookup. And each of these steps on the right, on the bottom right, have the logs for what's happening. So if you want to see each component of it, and I think I'll show those, we see them in real time and the output from them so you can see what's actually happening. So if we click on the Ollama chat model, we can see our input, all of the instructions that we gave it. We see from the quadrant workflow the output of the actual logs that we gave it. In the Ollama chat model, again, it's incorporated those logs into the prompt from our vector store. Then it's run the virus total lookup, and this is the actual IOCs that it pulled out of our logs, automatically enriched and queried. And there's our SHA-256 string that's being sent to virus total to say, is this malicious or not? The last step then is bringing that back to the Ollama chat model and providing an intelligent response out of it. And as you scroll through here, you'll see virus total has given us that log enriched with intelligent reputation information, and it's concluded that this is a malicious file successfully, or a malicious log detection. So we breeze through this really quickly. There's a lot to take away here. Most of the goal of this is not to give you something to go and necessarily recreate, but to inspire you to go and build something on your own here. So very quickly, some of the successes here, we get increased automation and efficiency, faster threat detection and response, improved productivity. Some of the challenges I ran into were hallucinations and inaccuracies, making sure that that prompt was extremely specific. And because I was running this locally on a crappy PC, I couldn't use a lot of the high-end frontier models. So if you want to get access to those and use those and not run them on a PC, you can use the cloud-based version to use some of those models. So for action this week, I encourage you to pick a use case that you're interested in automating, start to apply some automation, building in an LLM to use that, experiment with your prompt engineering and security context here, and even publish your workflow or template. So as I mentioned, there are a number of resources. One of the last ones here that you'll see, or didn't link them here. But if you go out to N8N, you'll see, oh no, it is there, the last one, N8N workflows. You'll see a community of workflows that have been developed and pre-built. Publish one there, hit me up on LinkedIn and show me kind of what you put together, or if you have any questions on how to build it. And all the resources that you need to complete this demo, this basic demo, are here. That automation framework that you can get off of GitHub is the first link here, and I highly recommend you playing with it. So apologize for rushing through the last couple of minutes here. You know how that goes. But I'll be around afterwards. Thank you so much. Hopefully this is inspiring. Go forth and build. Thank you. We do? Okay, we do have a few minutes for questions, so if you're not rushing off to your next session, stick around and I'm happy to answer a few questions. So go ahead. Anybody? Haven't played with Foundation AI much yet. As you know, every single day is like trying to keep up with a new major release. Definitely on my roadmap to check out. Have you looked at it? Have you looked at it yourself? No? So new, right? Yeah, exactly. I know. It's like no real work gets done at RSA, so, but definitely on my list of things to check out. Yeah.
Hi.
Yes.
Question. SIM logs can be huge.
Yeah.
How do you approach that in terms of giving the context we're talking
Great question.
about?
So SIM logs can be massive, and even if the logs themselves are small, you can deal with massive amounts of logs. You may have limitations on token inputs to the models that you're dealing with, so really important to drill down on the information that you actually care about. You'll probably have a lot of extraneous information in your logs that you can throw away or don't care about, reduce the model input size. But I highly recommend naming the fields or the areas of structured logs and throwing out the rest of it. So you can use nodes within your automation workflow to trim down or filter down the data that you care about in those logs. If you're dealing with raw logs and you need the full context of the logs, you're going to run out of tokens very quickly and it's going to get very expensive. So transform your data down. Good question. Next.
You dealt with the basic prompt, the more advanced prompt. Is there a piece where you tip over into a prompt that is too complex or creates problems by adding too much specificity?
Great question. Is there such a thing as too complex or too long of a prompt? I haven't seen one yet, but you can get too wordy in your prompt and you can end up driving hallucinations that way as well. So it's not as much about the length, but if you're overly wordy, you repeat yourself inconsistently, or you're not consistent throughout your prompt and your instructions, the model may get confused, it may hallucinate more, it may introduce things that you didn't intend. So when you're building that prompt, it's not as important to focus on the length of it, but more the consistency, specificity, and making sure that the questions you're asking are universal throughout it. But if you're around still, we're doing a live demo down at the Exabeam booth at 10 on our automation and our AI workflow, which we call Exabeam Nova. And the prompt for that is, I think, what, Carlos, over 5,000 words long, like a very extensive prompt to do what ends up being a generally simple task, but it has extremely specific and consistent instructions in there, and then it leverages a custom threat classification framework, which is part of that prompt as well. So I know there's a wordy answer, but I haven't seen such a thing as too long of a prompt yet. Thank you.
Can you please compare and contrast and predict for the future the sort of automation for LLMs you just demonstrated and what we have available in SOARs in common usage and have for a few years?
Yes. So I think if I understand your question, asking where automation is going to go with SOAR platforms?
And how they compare now.
And how they compare, yeah. As you stop around the expo floor and the booths, you'll see extensive IR automation for SOAR platforms. One of the things that I think we're seeing now is a lot of vendors claiming that they're integrating full automation and remediation for SOAR actions. And I think that's a bit of a misnomer. Even we are starting to work on building in the full end-to-end automation so we can autonomously take actions instead of just providing summaries, investigation, recommended next steps. We're already building the workflows to integrate and say, we've deemed this machine as malicious, alert the human being that we're going to remediate it, press yes or no, kick that back to an agent, and actually go and remediate the machine. That would be one example of a SOAR action that you might take fully autonomously end-to-end. There's a lot of vendors that are claiming they're doing it. Most are really not doing it, and it's very much human-driven. And to be honest, I think that's the right step for now. We still need human beings in the loop for some of these autonomous actions because LLMs are still hallucinating extensively, and there's a trust factor that needs to be applied. So I think in the next year, you will see full end-to-end automation applied to SOAR, and I absolutely believe that's the direction the industry is going.
Thank you.
Thank you. Yes, last question.
What are your thoughts about using LLMs for tabletop exercises as a moderator? Can you also integrate this use case well?
I missed the second part of it. Using LLMs for tabletop exercises on what?
Can you use such an LLM as a moderator for a tabletop exercise to help you train your incident response?
Yes. So training models in itself opens a whole new can of worms. We have, whenever we talk about the capabilities of a SOC that's doing automation and using LLMs, the number one question we get is, are you training with my data, right? Customers always want to know, are you building or training with my data? We've made the decision at this point explicitly not to train with data because you have data residency issues, you have major security issues, geographically you have all sorts of problems that come into play when you start to train on customer data. But one of our goals is to do that locally in our customers' GCP clouds, allow them to opt in to train on data and provide more tailored responses to their actual questions. Today, we use pre-trained models from Gemini to provide very specific answers, and we augment that with specific detections from their environment. So they get answers that are tailored to them without having to provide their data specifically for training. But super effective for tabletop exercise, for training and developing models. Highly encourage that.
Thank you.
Thank you.